guess the first thing that a lot of people have expressed some interest in are the names that we're going to use. We're going to call it Command Module Yankee Clipper and the LEM Intrepid. And as you know, these names were submitted by North American and Grumman personnel. And Brian tells me he has a sheet with the information on it. I'd like to say the Yankee Clipper was submitted by George T. Glacken of North American Rockwell. And each one of these men that submitted these names, we selected the names just based on the names. Each one of these men submitted a reason to the people at North American that reviewed the names first before they sent them to us. And that's in the statement. And Intrepid was submitted by Robert A. Lambert of Grumman. You have anything you want to say about the names, Dick or Al?
Well, I might just mention how we got started with this thing. I think it was kind of interesting. We all felt as a crew that this had been a crew's prerogative in the past, in Apollo at least, to name their spacecraft. And I think we decided that it did two things for us, really. First of all, just of the responsibility of selecting them, which is a considerable chore when you think about it. And I think it allowed the contractors, Grumman and North American, those two prime contractors for the vehicle, to help their people as far as morale is concerned by allowing them to identify more closely not only with us but with the flight itself. And both contractors received the ideas from the crew with a great deal of enthusiasm, and their people responded. We looked at the list of names, and there was some 1,500 to 2,000 from each contractor, and it was considerable. And some of them were very good, and some of them were a lot of fun. And this is what we came up with, and we're delighted that not only are the three of us in the Navy, but the terms are of some nautical significance as well.
I guess I understand that you all had some kind of a briefing yesterday from the mission planners, and I guess I'd like to talk for a few minutes about the differences between Apollo 11 and 12. We always had in our mission directive the statement to attempt a accuracy type landing, to work on the procedures for an accuracy type landing. And I guess just about the time that Apollo 11 landed, or shortly before, the people that pick the targets and select sites up in Washington decided that along with our accuracy landing, that rather than just say we'd try and land next to crater X, that we'd try and land next to something where if we do achieve that type landing, we could bring back some bonus type information and material. So they selected the Surveyor 3 site as our target. And ever since 11 landed, we have spent a great deal of time in working on the procedures, both looking at the data from Apollo 11 and working on the procedures to achieve this accuracy landing. Now, I guess most of you are familiar with where the errors came from as we know them today in Apollo 11. We had the water boiler on the LEM, which was producing some thrust. And as you know, we come up with the state vectors and the landing site targeting based on tracking through revs about 10 and 11. And they assume that nothing happens to the vehicles on the 12th and 13th revs. Although they track them, they don't have the time to process all the data. So first thing we've done, and we still don't have all the analysis back, is to maneuver the command module and LEM combination with balanced couples on the command module, which we didn't do on Apollo 11 because of thermal constraints of the command module thruster impinging on both the rendezvous radar and the LEM S-band antenna. We still do not have the answer yet from the engineers whether we can maneuver with the balanced couples or not. And if the thermal analysis shows that we can, we will. And that's one step in eliminating this down track error. The next thing that we did was work on the water boiler, and Grumman is in the process of coming up with a design to make the water boiler vent non-propulsive. I guess the most major thing that we've done is to take information that's presently available and try and find some way late in the game to update the targeting based on the latest tracking information after we make the descent orbit injection burn. I don't know if you're all familiar with the Lunar processor, but this high-speed data is going to be processed along with misfin Doppler data after we burn DOI and are acquired on the pass that takes us down to powered descent initiation. And I guess the biggest change we have is we have a change in our computer program which will allow us to go into the computer during powered descent and change the landing site based on the latest information passed to us from the ground. Now this change in the computer program would allow us to update downrange, cross-range, and landing site altitude. Presently, we don't plan to use either the cross-range or the altitude update information. The only information the ground is going to pass us is their best guess after PDI of what after we start powered descent initiation, what our best guess is to the down track error at that time. As you all know, when Apollo 11 lit the engine at powered descent initiation on the Lunar processor, they saw the 21,000 feet down track error. And hopefully we won't have a 21,000 foot down track error. We hope with the balanced couples and the non-propulsive venting that this will be eliminated, and we should have smaller errors, but we do have the ability to update. I guess the second biggest thing we've done is change the targeting of the final descent portion of the program, which is not a change to the computer program, it's just a change in the manner in which we target it, so that at 500 feet where Neil had about a 15 foot per second sink rate and 60 feet per second forward velocity at 500 feet on the normal profile, we'll have a 16 foot per second sink rate and an 80 foot per second horizontal velocity. We have found that this does two things for us. After we pass high gate, it gives us a constant LPD angle to the landing site in the region of 6,000 feet to 3,000 feet. And hopefully, if we don't have any computer alarms and Al and I don't have our head buried in the cockpit, we'll be able to pick up where we are. And if we are off track by visual observations, this program, this targeting gives us more capability to redesignate through the manual redesignation system, which has always been available in the computer program. It also will give me the ability to fly further manually in the region of normal manual takeover, which we used as 500 feet, and that's why I used the numbers 500 feet. We plan to take over somewhere between 700 feet and 500 feet, and if at that point we still are trying to achieve the target, we have a good deal of manual capability. I estimate from the simulator that we have the ability to probably fly out another mile of downrange air. Now that would be, if we flew out that other mile of downrange air, there'd be a lot of nervous people on the ground, but we can do that and have adequate fuel reserves. I guess the next thing that's different on 12 from 11 is our stay time. We're staying for 32 hours. We plan to power down our inertial measuring unit on the lunar surface, which was not done on Apollo 11, in order to conserve electrical power, and this is a change. We have a great deal of confidence in the guidance system, and we don't mind shutting it off. And then, of course, the two EVAs. Then the other thing is we're going to spend another 24 hours in lunar orbit, and I'm going to ask Dick to give you a rundown on the operations in lunar orbit that he intends to perform. We're trying to get efficient. Dick has some experiments to do while we're down on the lunar surface, and he'll give you a little rundown on that. Also give you a rundown on the bootstrap photography. We're going to do a plane change after we come back up and jettison the LEM and stay an extra 24 hours to get this photography for the follow-on flights. and I'd like to ask Al to give you a little rundown on the lunar surface operations. Why don't you talk about the orbital operations first, Vic?
Well, I guess first and foremost in the activities, not only alone, while Pete and Al are performing the lunar surface EVA, is an old experiment. It's old in terms of flights. It was flown on Apollo 9. It was called SO-58 at the time. It's S-158 on this particular flight, and it's essentially the same experiment using virtually the same hardware. And we consider it one of the better experiments that we have flown to date. What it is actually is multispectral photography of the lunar surface. It utilizes 4 Hasselblad cameras in the hatch window. 3 of the cameras have black and white film with various filters on them. One has a green filter, one a red, and one a blue. The 4th camera on the arrangement for the hatch window has IR film in it. Now, the intent of this is to more or less photograph the illuminated side of the moon from 1 minute after sunrise to 1 minute prior to sunset in a strip manner, or in other words, every 20 seconds these cameras will be activated so that we'll have complete strip photography across the surface of the moon using this technique. 2 passes, 2 revs will be devoted to this. The bootstrap photography, I think, is probably one of the more important things we're doing on this flight, not for ours certainly, but I think for the follow-on missions. As you're most likely all aware, there's been a lot of discussions in the past on future landing sites. When do we start going into the, I guess you would say, the more interesting areas of the lunar surfaces, geologically speaking. Obviously, this includes highland areas as well as the flat plain lands that we're talking about now. Unfortunately, we really don't have the photography required to train the crews adequately to go in there. So this is one of our significant responsibilities after the lunar landing, the EVA, and the rendezvous is concerned. We have to jettison the LEM 2.5 hours after the rendezvous. The intentions are at this time is to impact the ascent stage of the LEM on Apollo on Site 7. In other words, near or in close proximity to our landing site. From then on, it's a rest period, but very shortly thereafter, next morning, a plane change is to be made to more or less put us back over the same ground track that we have been in the previous days. There are 3 areas of genuine interest as future landing sites. One of them is Lalande, and the other is Descartes, and the third being Falmaro. Now, these 3 areas will receive considerable attention as far as photography is concerned from our crew. We have a Hasselblad camera with a 500 millimeter lens that will be mounted in the right window, and we'll use the DAC, the data acquisition camera in the left window with an 18 millimeter lens to photograph these sites. Now, the oblique photography that will be taken requires fairly precise tracking by the command module to utilize what we call target motion compensation so that the resolution that's inherent in these cameras will be actually realized on the film, so that the crews that follow us will have adequate training and recognition of these sites. And the rest of the bootstrap operation is doing landmark tracking, or in other words, utilizing the P-22 program so that we can nail down the control points and also the actual landing sites themselves. There will be 2 revs of the P-22. Additionally, there will be 2 revs of what we call strip photography, where the data acquisition camera will be mounted on the sextant, and at the same time, the Hasselblad with the normal 80 millimeter lens will be mounted in the right-hand window, and we'll take stereo strip photographs over this same ground track for future use by the follow-on crews. Now, I think that basically covers those additional items that we're required to do that are sort of the tail end of our flight, and we call it bootstrap photography, but I think recognizing future landing sites, you can see the tremendous importance of our obtaining this type of information.
Yeah, I might add one thing here. I call it Shades of Gemini 5. With all the cameras and stuff they've stuffed in that command module, I'm sure we're going to have the world's greatest zero-G juggling act up there getting all these pictures taken. Doesn't sound too splashy, but it's going to be a lot of fun, I think, to get the job done. We have this plane change and first photography of Lalande in about 40 minutes, and the command module is not designed for rapid operation up there, so I think we've got our hands full on this. Dick's done a great deal of work on it, and as he said, this photography is very, very necessary for the follow-on flights. Al, would you talk a little bit about the ALSAP and our lunar surface operations, please?
Okay. As you well know, we've got 2 EVA operations on this flight. Both of them right now are 3.5 hours, but the second one is sort of an open-ended situation where, depending on the amount of consumables we use in the first, we're going to be able to perhaps make the second one a little bit longer than 3.5 hours. What we're going to do is weigh the water when we get back in, the amount of water that remains in the Bliss, and from that be able to get an idea of how much longer we could safely stay out perhaps the second time if we work at the same workload. So we're hoping that the second EVA perhaps will be a little bit longer, which will allow us to get a little bit more done. In fact, we think that the major thing that we're going to do on this flight as far as EVA is concerned is try to nail down as well as we can how much can be done on a 30-hour lunar surface day, 30 or 32, somewhere around in there, lunar surface day. How much time has got to be devoted to check out, to sleep, to prep for the EVA, post and that sort of thing, and then how much time then is left so that you can get out and actually do the science experiments or engineering experiments, whatever is planned to do in the total lunar stay time. So what we've done is sort of packed our 2 EVAs as full as we could, as full as we thought we could get done on the basis of our previous training, what they found out on, what Neil and Buzz found on 11, and what we've worked on since then, so that we're going to do what we think is the best possible combination of jobs. I think when we get back from here, we ought to be able to have a good handle in on totally how much you could do on a 30-hour mission. Our first EVA, as you're aware, is devoted largely to getting the ALSEP out and deployed. We've had several different proposals about where to put the ALSEP relative to the LEM, but as a result of 11's experience with their ESAP, they've done some thermal analysis and some more analysis here concerning just where to put it. So right now what we'd like to do is take the ALSEP out about 1,000 feet to directly west of the LEM and put it out in that direction. This is considerably further away than the 200 to 300 feet that we'd been working with before. And 1,000 feet is a pretty long distance from the LEM in those suits. But we're going to try to get it out as far as we can, not further than 1,000 feet out to the west. I don't think I'll say anything about the individual ALSEP experiments. I know you've been briefed on them. I know that you're aware of what each of them does and what we hope to accomplish with each of them, the differences between our experiments and the ones that they put out with the ESAP on 11. The second EVA is largely devoted to selecting some, or doing some documented geology, and we had an exercise in New Mexico yesterday, Arizona, Flagstaff, Arizona yesterday, to work with Houston and to try to work together as a team to do the geology that we had to do. This is going to be one of the differences, I think, between our particular work with in the geology area than we saw on 11. As you recall, on 11, they had a number of things to do in their EVA time. They got out, they did the evaluation, they erected the flag, they deployed the ESAP, and this sort of thing, and they had a pretty rigid timeline that they adhered to, got the job done, and got back in. Now we have sort of the same thing, but in the geology area, what we plan to do is not only work our plan, but we plan to keep the science support room in the Mission Control Center up to speed as much as we can on what we're doing, where we are, what we're seeing, so that the geologists there, the scientists there, can take a look at what we're doing, look at the maps, the orbital photograph, and whatever else they have on hand there, and then try to assist us, sort of make it a two-way interchange so that we can get the maximum science out of the several hours that we're going to devote to the geology or the documented sample on our second EVA. That's about all I can think of, Pete.
I guess the other, one other item that came to me that'll be different, we still have our fingers crossed on it, although we're planning on it, is color TV from the lunar surface. Now, we didn't pick color because we thought it looked pretty. We picked the color because it gives the best motion resolution, if you remember the phantoms and the ghosts and so forth. And one other item about it, we do have adequate signal strength, but it may be, as you know, we plan to deploy the S-band directable on the lunar surface on the first EVA, and we won't have it in operation until after we get back in. And could be that we have a little better TV on the second EVA than on the first with that little bigger antenna. I don't know whether it will make any difference or not, but we should get a little better signal out of the S-band directable if it works right and I get it pointed right. So that's a difference. I guess the other thing that hasn't been mentioned here is if we do land close enough to the surveyor, what we intend to do with it. It's an interesting item, and we have gone out to JPL and met with the people out there, and people at headquarters and here in Houston have reviewed all the things that could be done with the surveyor and have selected in order of priority those things that they would like to have done if we get to it in a proper amount of time. And as you realize, the surveyor is a secondary objective to the geology and the ALSAP, and therefore we'll leave that till the very end. Now, if we get to it, there's several problems that have come up. The surveyor's inside a crater wall. It's entirely possible it'll be out of sight of the LEM when it's on the lunar surface, so we went through an exercise on communications, and it looks like right now that even though we're out of line of sight to the surveyor, that our plisses have enough power that we don't need line of sight, that we should have adequate comm. Of course, if we don't, as you know, on the new plisses, which were used on the lunar surface, one of them is a slave and one of them is the master as far as the radio relay goes, and it turns out that my number one pliss is the master and Al's is the slave, so if we lose comm going down in the crater, Al gets to go all the way down, and I'll act as the sorry about the slave. Al had gone down to the surveyor, and I'll act as relay because we do have to have adequate comm. In that case, the way we've planned that portion of the EVA, Al is going to take all the photography around it. And I think some of the things that may come out of that are pretty darn interesting. Of course, the surveyor's been there some, I think, 31 months, and Al plans to take some close-up pictures, which would be taken in roughly the same location as close as he can get to the TV camera of the very near surface, which the TV camera documented very, very well. And the scientists would have a look at this surface in great detail to see what changes have taken place to the lunar surface over 31 months. Now, as you know, I guess the geology of the moon has turned out to be a lot older than many people expected it to be, and it's really hard to say whether they would find any changes in it or not. There's other photography that we're interested in, and I won't go into the detail. There are 4 objects that we've decided, I say we, the powers that be, have decided are the most worthwhile to bring back from the surveyor. And on the top of some electronics packages were glass insulation to act as thermal insulation. These are small glass panes, 2 by 3 inches roughly, very thin. And they would like one of those back. They've been exposed to micrometeorite and this sort of thing. There is a portion of aluminum tubing that's very shiny, polished aluminum tubing that sort of would act like a long-term solar wind collector and micrometeorite, in which we plan to chop that off with these bolt cutters that we have.
And then there's the TV package, which has two things on it. There's wiring to the TV package, which we're going to try and bring back in a sterilized can for the people that like to look at organisms and see what happens to them up there. And then there's the TV camera itself, which weighs about 17 pounds, Earth pounds. And the TV camera, of course, has all kinds of interesting things in it. It also has a mirror, it has its lenses, it's got plastic, it's got electronic parts, wiring, insulation, and various metals. All of this being exposed to this long duration, 31 months vacuum and space environment, which they feel would be very valuable in analyzing for future design. To bring that back, we've come up with a very super modernistic knapsack, which hangs on my back, although I called Al a slave. I get to carry all the hardware back, so you can't say that we're not sharing the load somewhat. And I hope we get to it. And
It's been bothered.
yeah, it's been bothering me. That's right. Well, I dream about it at night.